What is the topic today? Today's topic is halogen alkene. Halogen alkenes means these are alkenes containing halogens. There are many halogen alkenes depending on halogens. There are chlorine, bromine, iodine, anything could be there, or could be different carbon chains, different alkenes with same halogen. They're diverse, there are many. Okay, the general formula could be CnH2n plus 1 and a halogen. Here you see chlorine is a halogen. Instead of chlorine, you can write, if this is chlorine, Cl, or bromine, if this is bromine, etc. So these are all halogen alkenes. And we can make halogen alkenes from different ways. I can show you how we can make halogen alkenes. One could be from alkane. I write here alkane, and from alkane you can make halogen alkene. And you're supposed to know the reagents required for making halogen alkene from alkenes. Simply with halogen, chlorine or bromine, I write here X2. X2 means the halogen, and here the condition is important. This should be sunlight. Okay, UV light or should be here sunlight. So alkane give halogen alkene, and not only alkane, we got alkene. This is a better way, easier way. And from alkene we can make halogen alkene. Here the reagents could be again halogens. I write here chlorine, bromine, iodine, or hydrogen halides. If you use halogen with alkene, you will get dichloro or dibromo or diiodo alkane. Or if you use hydrogen halides, then you will get single chloro, just suppose monochloro or monobromo, this type of alkene. And alkene doesn't need any condition for the reaction. And then alcohol, from alcohol you already learned in just previous chapter, from alcohols you can make halogen alkenes. Actually reagents are many depending on what type of halogen alkenes you're going to make. If this is chloroalkane, then PCl5 was there, or concentrated hydrochloric acid is also a choice. If this is bromoalkane, then HBr or PBr3 could be used, or phosphorus and iodine together. Phosphorus and iodine if you want to make iodoalkane. So this is how you can make halogen alkenes from alkene or alcohol. I want to show one of them. Just instead of alkane, I can write here CH4. If this is CH4 and you are using here chlorine, then you know what would be the chloroalkane. This would be here CH3Cl. Okay, this is a chain reaction. This would be free radical substitution reaction you learn. And if this is alkene, I say here alkene could be here CH2 double bond CH2. And if this is chlorine, then you will get here. I write them separately here because products are different. CH2 and Cl. This is 1,2-dichloroethane. If this is hydrogen chloride, then product would be different. What would be there? This would be CH3, CH2 and Cl. Okay, and for alcohols actually, if this is ethanol, right here ethanol, C2H5 ethanol, and you add PCl5, then the alkane will be, halogen alkane will be chloroethane. And if this is PBr3, PBr5 is not possible because not stable. Then you would get here C2H5Br bromethane. Or if this is iodine and phosphorus, and you would get here C2H5 iodine. So these are the compounds, and we just started. Then we are having a review. because we studied them, how to make them. So these are all about making halogenalkanes. And then what's next? Physical properties. And physical properties, halogenalkanes do not have high melting and boiling points because they do not have a functional group to make hydrogen bonds, and their poles are weak, the dipoles are weak. When the dipoles are weak, the intermolecular forces are also weak. But if the molecules are very big, they would have higher melting boiling. But generally, if you compare with other substances with similar masses, then you would get halogenalkanes with lower melting and boiling points. Another thing, physical properties, solubility in water. They are unlikely to dissolve in water because I already have mentioned that their dipoles are weak, and when the dipoles are weak, they are less likely to dissolve in water. So they form separate layer if they are added to water. And these are there. And now we'll see the reactions, chemical reactions. And as they do not have very active functional groups, so they are not highly reactive, but they react. We get some reactions with them. Basically, the reactions are substitution reaction. They got halogen, and halogen could be replaced with other substances. The other substances are nucleophile. Why are nucleophile? Because here a positive carbon atom which contains the halogen. I may draw a halogen alkene. Is chlorohalogenalkene would be here CH3 or this. This is a halogen alkene, and this is primary halogen alkene. Why is primary halogen alkene? Because this is primary halogen alkene because this carbon, chlorine containing carbon, is bonded with two hydrogen atoms. And if this central carbon is bonded with only one hydrogen atom, suppose this is here CH3, another CH3 I'm adding here, this is now secondary halogen alkene. And if this contains another CH3, then this would be tertiary halogen alkene. Okay, so whatever is it, primary, secondary or tertiary, this is partially negative and this is partially positive, though you know the dipoles are not so strong because chlorine is highly electronegative, but this is bonded to carbon. Carbon is not very poorly electronegative element. This is also somewhat strong electronegative element. So when it is polar, then some other substances to be nucleophile. Nucleophile means looking for nucleus or positive center. The attack should be with opposite side. We're gonna see two reactions. Both are similar reactions. Nucleophilic substitution, one with water, another with sodium hydroxide, aqueous sodium hydroxide. Here you see I write CH3, and if this reacts with water, H2O, product would be the ethanol here, CH3, CH2, OH, which is coming from water, and another hydrogen is left, and this hydrogen will combine with chlorine to form hydrogen chloride. So this is a reaction, this is a nucleophilic substitution. Chlorine has been substituted or replaced. Another reaction I'm going to write here, CH3, CH2 and Cl, could be Cl, and this is with OH minus, alkali here, aqueous to be given here. And then the reaction will be similar, substitution reaction. You would get here CH3, CH2 and OH. This OH has substituted this chlorine, and you would get this time chloride, the halogen as halide ion. Secondly, sodium hydroxide was there, or any other hydroxide was there. That means this contains a metal. The metal ion must be there with OH, which cannot be alone. That metal ion combines with this chlorine and forms sodium chloride, or like this. So these two are substitution reaction. Now the question is, which of the reaction do you think is easier or more likely to happen? The second reaction is more likely to happen because here OH is a free ion. Okay, OH doesn't need to be formed. Okay, so OH is free. It is an ionic compound. Sodium hydroxide was there. Sodium was bonded with hydroxide. So ionic compound, when dissolved in water, they're already separate. So there's nothing to break the bond. There's no question about to break the bonds between sodium and hydroxide. It's already broken. So this can easily substitute this chloride, and this is easier. Okay, and for this is not the same fact. Here OH is not ready. Water means water is this. You first need to break the bonds, break the covalent bond that needs energy, and when you break the bond, then OH form. Then OH will substitute this chloride. This is why this reaction is faster and easier and needs less heat. And first reaction is reversible. You already got that this reaction you started ethanol and hydrochloric acid. If you mix ethanol and hydrochloric acid, they react to give chloroalkane. And here we are getting ethanol from chloroalkane, which means the reactions are reversible. And this reaction is not reversible. This reaction goes to the completion because what is there? OH is free there. So these are two reactions, comparative two reactions. And another reaction, which is an elimination reaction. What does the elimination mean? Something is removed. Okay, something is removed. And this reaction, what I'm going to talk about, is very interesting and very important because the equation I write here, CH3, CH2 and Cl and OH, and this reaction gives CH2 and double bond CH2 and HCl. This is the reaction. I write here again OH. Then later OH and HCl will react to form water and chloride ion. So this is the first form. These two are first form, and then later form water and chloride ion. And there must be a metal. Then metal will form sodium chloride. And look at the reaction carefully and see how is the reaction peculiar. In this equation you get chloroethane reacting with hydroxide, and that is giving substitution reaction. Alcohol is the product. And in this equation you get the same thing. Here you get chloroalkane and reacting with OH. But this time you get alkene here, and with water and chloride formed in this reaction. So both the reagents are same in these two equations. Reagents are same, but the reactions are not same. They are the different products. So this is interesting thing, and this is very important for exam, especially in the exam. The difference caused by the condition, not caused by the reagents. In both the equation you get halogen alkane, hydroxide, but basically the conditions are different. Conditions, this is aqueous. Okay, the first hydroxide is aqueous, which acting as a nucleophile. But this equation, OH is not aqueous. When OH is not aqueous, this is somewhat OH is dissolved in alcohol or organic substance. Okay, without water actually. OH is not having water, so this is dry or alcoholic OH. This is why you get the total reaction is different. Elimination reaction you get here. And in this elimination reaction, I'm going to show again. If I write the displayed formula, the chloroalkane, and chloroalkane is reacting with what? With this hydrogen and chlorine. Look, chlorine from one of the carbon atom and hydrogen atom from the neighboring carbon atoms. These two combine and form hydrogen chloride. And this hydrogen chloride is here, hydrogen chloride, this hydrogen chloride gone. And then this hydrogen chloride will react with OH. Here OH is acting as a base. Here OH is, in this reaction, OH is acting as a base because that is extracting a hydrochloric acid or hydrogen chloride and neutralizing the hydrochloric acid. That means OH is a strong base, being a strong base, non-aqueous, neutralizing the hydrogen chloride, and this is why you get this reaction, this elimination reaction. But here the role of OH is different. If OH here in this equation or in this reaction nucleophile, and OH here in this reaction as a base. Okay, base. So here this happens the elimination reaction, and here this was a substitution reaction. I hope these things are clear. If this is the reactant, and if you add sodium hydroxide and heat this elimination reaction, here chlorine has two options. Chlorine gets two options. One, chlorine may take this hydrogen of this carbon to make double bond between these two carbon atoms. And if this happens, that chlorine takes this hydrogen to form hydrogen chloride and double bond forms between these two carbon atoms. Product after this hydrogen and chlorine gone, you would get this product is but-1-ene. But if this happens, that chlorine takes this hydrogen to combine with, then what would be the product? The product would be but-2-ene. Then you would get here double bond forms between these two. This is the interesting thing. When you get things with puzzle, then that is very important for the exam. So always remember, if you hit this substance with sodium hydroxide, okay, sodium hydroxide is a reagent, okay, what would be the products? So your job is now draw the products, possible products, and I'm giving you condition. This is aqueous, or another options here. When this is dry or alcoholic, you again heating sodium hydroxide with 2-chloropentane, okay, sodium 2-chloropentane, but alcoholic. So what would be the possible products? So now you draw. And I now want to show you another reaction. This reaction of again halogen alkene with ammonia. This will be the similar reaction, nucleophilic substitution. Here the ammonia, nitrogen has a lone pair of electron, and this lone pair electron will attract the central positive carbon and will have the reaction. And products will be, you get CH3, CH2 and NH2. NH2, not NH3. Here one hydrogen is left and here is a chlorine substituted. These two together will combine and form hydrogen chloride. One thing is very important for this reaction, which is the condition. The condition should be alcoholic. Another thing, you need to heat warm for the reaction because ammonia, that larger amount of ammonia will combine with hydrogen chloride to form ammonium chloride. So when you get now see another reaction. The reaction is with cyanide. Suppose potassium cyanide. Here we get again halogen alkene. This reacts with cyanide ion. This is basically potassium cyanide or sodium cyanide, and this will also replace this chloride. Actually reactions are similar, and the products you will get CH3, CH2 and CN. Here chloride has been removed. This is the product you get. And here the medium is also alcoholic medium, like the previous reaction. The reaction occurs in alcoholic medium, and you need to heat for the reaction. And if you need to heat for longer period of time, you need to heat under reflux. Interesting thing is the name of the product is no more cyanide. This is coming from cyanide, and we may write as potassium cyanide or sodium cyanide. When they're ionic compound, they are called cyanide. But when they are not ionic compound, I mean this cyanide, CN bonded to carbon, they are no more called cyanide, they are called nitrile, another homologous series. Look, how many carbon is here? 3 carbon. 3 means propane. 3 means, certainly you know, 3 means propane. So its name is propane nitrile. And if this contains 4 carbon atoms, it could be butane nitrile. So this is how their names work. They're simple. This nitrile word is added with alkane, propane, butane, pentane, hexane. What is that? So this now is reaction mechanism. You already got the name of the reaction mechanism, which is nucleophilic substitution. So this is primary halogen alkene, and certainly this should be partially negative and this should be partially positive. So this is why a nucleophile will attack this carbon, because this is partially positive. Nucleophile would be here. You already get that OH ion could be if this reacts with aqueous sodium hydroxide, then aqueous sodium hydroxide contains OH ion. This lone pair is going to attack carbon to make a dative bond. Look carefully. Carbon already having 4 bonds. Can carbon make another bond with OH? No. But but this happens actually. How this happens? We may write a transition state where we show again, look at the central carbon. I'm going to show the central carbon again. This central carbon was with hydrogen and central carbon was with CH3 and this hydrogen. Now OH is trying to make a bond with this carbon. Look, I give this bond as dotted bond. Okay, so OH is trying to make a bond with this carbon and weakening the bond of carbon and chlorine. Look, carbon and chlorine, this bond getting weaker. So this is an intermediate, or you can say that this is in between. Okay, so this is happening. It should have a minus sign. Both are trying to make the bonds, both OH and chloride. Which one will be there? One of them will be there. There's fighting, like they're fighting, and ultimately chloride is removed because this is a substitution reaction. This must be removed. So ultimately you will get the product. I write the product here. Here is carbon and OH is bonded. This bond forms here, and previously bonded substance were a methyl group, and here chloride ion is gone as a byproduct. Chloride is gone. This is the first step. This is an important step, and you may show this in our new book. In many books, this step is missing. This step is not shown. Just showing this and this, but they show another bond breaking. It's a heterolytic division of this bond. Just when OH is trying to make a bond with chlorine, and simultaneously they show that this bond is breaking down. Carbon and chlorine bond is breaking down together, and when this bond is broken and this bond is formed, you directly get this product. Then you don't need to write this intermediate or this fighting between them. Okay, I think for you this is better. This is better that you just write this, and you need to show this OH from opposite side of the chloride ion. Partial chloride, because chloride is partially negative and OH is also negative, so the negative would be a repulsion, so they won't be together. So OH must be coming from the opposite side of the chloride ion. And the most important things are the curly arrow. Curly arrow should be very important and very precise. Starting and ending, position of the curly arrow are very important. If you place the curly arrow, then you would not score the marks. There are many mistakes students make. Suppose I show you here the mistakes they make. Look, this is a mistake. This means the carbon is going to chlorine. Carbon is going to meet chlorine. This is not true. Or if you write this, this is also not correct, because the bond is going where? Going to commit suicide. This is not right. So the right thing is start middle of the bond and towards the atom, towards the atom. This is right. And similarly here, this arrow sign is also important. If you show that OH is going to make a bond with carbon, this is wrong. This is not right, because not OH, it's a lone pair of electrons. Here should be the lone pair of electrons you get on oxygen. You clearly should show the lone pair of electron moving to this carbon, perfectly this carbon, to make a bond. And the curly arrow should be curly. You should not write a straight line, like this straight line is not allowed. You get marked for this. Or if you get this type of arrow, this will not score any marks. So it should be just curly arrow. Okay, curly arrow. You need to know how this happens. So this is the mechanism of the reaction. It's very important. You need to practice. And after I erase this, I ask you yourself try to draw this again.